So these problems say use the square root property to solve equations. So they're telling you what to do. You know, a quiz probably wouldn't. Solve each equation, check the solutions. I'm going to zoom in on this and rewrite the problem. So we got a plus 4 squared equals 49. Now you might be tempted to FOIL this out and rewrite it. And you could probably factor and do all that kind of stuff after you subtract 49 from both sides. But here's the deal. When you look at this and pause for a moment, the right side only has a number. The left side has a square root. And this looks like one of those numbers that's nice to take the square root of. So I'm going to show in the same rewritten problem step, taking the square root of both sides, which is going to leave me with a plus 4 equals 7. But it doesn't just equal 7, right? It could equal positive or negative 7. And I point that out because it really matters. Now notice that I didn't slap the positive negative over here, although I could have. And also notice that nothing really happened with the 4. Now, we still don't have a by itself. I'm going to subtract 4 from both sides. That leaves me with a is equal to, but here's how I have to write this. The negative 4 is just negative 4. So I'll write that first. The plus or minus 7, that's where the plus or minus is attached. So I'm going to write plus or minus 7. And since I can add 7 or take away 7, I'm not going to leave it written that way. I'm going to write a is equal to, well, negative 4 minus 7 is negative 11, while negative 4 plus 7 is positive 3. And it says, check your solutions. And the cool thing is we can check it way back here. So let's plug in negative 11. Negative 11 plus 4 is negative 7. And if I square that with parentheses, I would get positive 49. That's only checking one of the two. So now I'll check positive 3. And 3 plus 4 would be 7. And 7 squared would be 49. Give yourself a moment to process that one if necessary, and we'll check out problem 2. I'll rewrite it. Z squared plus 2z plus 1 equals 16. Yeah, I could subtract first, or I could realize that this is a perfect square, and I would write z plus 1 squared equals 16. Then it's very similar to the last one. Square root both sides. And then you would have z plus 1 is equal to positive or negative 4. Subtract 1 from both sides. So z would be negative 1 plus or minus 4. And on purpose I am showing this as kind of an extra step, which would give us negative 5 because negative 1 minus 4 is negative 5, or positive 3 because negative 1 plus 4 is positive 3. Let's check negative 5 and 3 in this original equation. Here, if I try negative 5, probably doing this in my calculator, this becomes 25 minus 10 is 15 plus 1 is 16. And the reason I do it in my calculator is because when I go in, I can just change the previous values and put a 3 in its place where I saw a 5. 3 squared would be 9 plus 6 is 15 plus 1 gives us the right side of 16. The last problem. Now, even though I'm over here, I hope you're working in either columns or working your way down the page, so you know you're not stuck trying to make this work in the corner of the page. All right, unlike the last ones, we now have something we can't nicely take the square root of, getting a whole number. So here's how we're going to get to this next step. Y minus 8 is equal to positive or negative square root of 7. Then I go in, to get y by itself, I add 8 to both sides, and I'll have y is equal to 8 plus or minus the square root of 7. This right here is completed. We wouldn't write it as plus or minus the square root of 7 plus 8, but we could. It's just more conventional to see the integer first as opposed to the irrational number. Also, depending on how you'll see some of these in the back of the book, you could plug these values in, like to a calculator, and type in 8 plus the square root of 7, which would give you this value, or 8 minus the square root of 7, which would give you this value. But in higher math, you often most commonly leave it with the plus or minus shown, because whenever possible, you steer clear of approximation. So depending on whether or not it's a word problem, depending on how you'll see this presented in the future, that's what we're dealing with. So if you see instructions that say round to the nearest tenth or hundredth, follow what they tell you appropriately. In problems like this, it's nice to do these a little bit rote, meaning practice, 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 practice. And then once you've done a bunch of these, hopefully you just kind of picture them and see how they work themselves out. So this is an assignment that goes with that.